In a vast cosmos brimming with infinite possibilities, one question echoes through the depths of our collective curiosity. Are we alone? Join us on an extraordinary journey as we delve into the captivating realm of astrobiology, where science meets wonder and the quest for life in the universe unfolds before our eyes. From the unexplored corners of distant exoplanets to the hidden depths of icy moons, we embark on a cosmic adventure to seek out the tantalizing clues that may reveal the secrets of extraterrestrial life. Astrobiology. Astrobiology is the field of science concerned with the study of life in the universe and attempting to solve the mystery of how life emerged on Earth. This includes the search for life beyond Earth, studying environments that could support life, as well as investigating interactions between planets and their stars and exploring how this could influence life. As such, astrobiology is very much an interdisciplinary endeavor encompassing a wide range of scientific fields such as, but not limited to, biology, astronomy, chemistry, geology, atmospheric science, oceanography, and even aeronautical engineering. A relatively young scientific field, astrobiology, has already had a major impact on how space agencies like NASA and the European Space Agency, ESA, conduct and plan their off-world missions. What do is an astrobiologist do? For as long as humanity has understood that the stars in the night sky over Earth are bodies similar to the Sun and thus likely possess planets of their own, we have speculated about the possibility that these worlds also host life. Finally, our methods of scientific investigation are catching up to our aspirations, and scientists are beginning to search for clues of life away from Earth. Astrobiologists study the possibility of life beyond Earth. They may be experts in biology, but could also be qualified in a wealth of other scientific fields, such as astronomy and chemistry. Astrobiologists may look at the simplest forms of life on Earth or those that live in extreme conditions like temperature extremes and under high pressures. This allows them to ask if such organisms would be able to survive in space or the extreme conditions of an alien world. Exobiology and astrobiology. Arguably one of the foundational experiments in astrobiology was 1853's now infamous Miller and Urey experiment. Scientists from the University of Chicago, Stanley Miller and Harold Urey, simulated conditions on the primeval Earth and showed the chemical compounds that are considered the foundational building blocks of life arose naturally from simple chemical processes. Their experiment found that with just water, ammonia, hydrogen, and methane, as well as an electrical spark to mimic lightning, several protein precursors necessary for life, including amino acids, were formed. NASA would perform its first astrobiology mission in 1959, initially referring to the field of study as exobiology, by designing an instrument to score extraterrestrial environments for the science of microbial life. This would lead to the foundation of NASA's Life Sciences program, which became the responsibility of the Ames Research Center, RC, where exobiology would eventually broaden its horizons and become the field of astrobiology as it exists today. Astrobiology in the solar system and beyond. Since Viking became the first mission to successfully touch down on Mars, there have been a wealth of missions on the red planet's surface and in its orbit, providing crucial information for astrobiologists. These missions include the now retired rovers Sojourner, Spirit, Opportunity, and Curiosity rover, and the currently active Perseverance rover, which touched down on the Martian surface in 2021. The Perseverance rover, part of NASA's Mars 2020 mission, is currently providing important data relevant to astrobiology research from its stomping ground on the red planet, the Jezero crater. This 28-mile, 45-kilometer wide crater is believed to have flooded with water around 3.5 billion years ago. With water considered a key element for life, Perseverance is looking for biosignatures that indicate life once existed in this region of Mars. The rover has recently begun dropping sample tubes on the surface of the red planet, which will be picked up by the joint NASA/ESA Mars sample return mission shortly. Astrobiology and exoplanet. Outside the solar system, astrobiologists are beginning to study the atmospheres of so-called extrasolar planets or exoplanets to determine the kind of elements and chemical compounds that comprise them. The investigation of exoplanets is a relatively new science, but is growing at a staggering rate. This is exemplified by the fact that the first exoplanet around a sun-like star was discovered in 1995 by the team of Michael Mayer and Didier Queloz, and in just 17 years, the exoplanet catalog had grown to over 5,000 confirmed worlds. In December 2021, the James Webb Space Telescope, JWST, the most powerful telescope ever built by humanity, launched and quickly began to revolutionize astronomy and space science. NASA says the JWST's impact on astrobiology comes from its ability to observe the formation of stars from their first stages to the formation of planetary systems, thus allowing astrobiologists to observe the kind of elements that are present as planets form. The JWST is also capable of measuring the physical and chemical properties of planetary systems and thus allowing astrobiologists to investigate the potential for life in those systems. Here are a few examples. Kepler 186f. Discovered by NASA's Kepler spacecraft, Kepler 186 is an exoplanet located within the habitable zone of its star, Kepler 186. It is approximately the size of Earth and orbits a red dwarf star. Its position in the habitable zone suggests the possibility of liquid water, making it a target for astrobiological investigations. TRAPPIST-1 system. The TRAPPIST-1 system gained significant attention in astrobiology due to its 7 Earth-sized exoplanets. 3 of these planets, namely TRAPPIST-1 E, F, and G, reside within the habitable zone. Researchers have been studying these exoplanets to assess their potential for liquid water and the potential for habitability. Proxima Centauri b. Proxima Centauri b is an exoplanet located within the habitable zone of Proxima Centauri, the closest star to our solar system. This rocky planet has drawn attention as a potential target for astrobiological investigations due to its proximity and potential for hosting liquid water. NASA's plans for Astrobiology. The study of exoplanets and their atmospheres, and thus astrobiology, received another significant boost at the start of 2023 when NASA unveiled plans for a future telescope to succeed the JWST. The primary goal of this telescope, the Habitable Worlds Observatory, HWO, will be to search for the signs of life on Earth-like worlds. The new space telescope could be operational as soon as the 2040s and will be designed for robotic servicing and upgrades, which means not only could it operate for decades, but its observing power could improve with age. The HWO should be capable of detecting the signs of life on 25 nearby Earth-like worlds, the statistic minimum that astrobiologists and other scientists need to determine if life is common in the Milky Way. As we delve into the captivating realm of astrobiology, the search for life in the vastness of the universe becomes a cosmic odyssey that stirs the depths of our curiosity and imagination. Every step we take in this quest brings us closer to unraveling the mysteries of our existence and understanding our place in the cosmos. Astrobiology ignites a flame within us, reminding us that the universe is an endless expanse of possibilities, teeming with potential for life beyond our wildest dreams. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.